Hello geometry students. In this video we are going to learn about proportions and similar figures. We are going to identify corresponding angles and side lengths in similar figures and find missing side lengths using proportions. Okay, so first let's talk about what it means for some shapes to be similar. Similar means that they are the same shape but a different size. When we talked about congruence meant that they were the same shape and the same size. Similar is the same shape but different size, but they're scaled up proportionally. So if two shapes are similar, then that means that we have two things. We have the corresponding angles are congruent, and the corresponding sides are proportional. Okay, so if the corresponding angles are congruent, then that means the corresponding angles are congruent. Take a look at these two triangles right here. They are oriented the same way. We can tell which parts match up with each other. Angle S matches up with L. These are corresponding. They are congruent. Angle S is congruent to angle L. Angle I and angle A match up. So we'll put some marks on them. Angle I is congruent to angle A. And angle M and angle R match up. So we'll put our congruency marks on them. Now they're not all equal to each other. So it is important to put the 1 mark on S and L, 2 marks on I and A, and 3 marks on M and R. We also have our corresponding sides are proportional, meaning they're in the same ratio. So I'm going to use my colors a lot in this lesson. I really strongly encourage you in this topic to use highlighters or colored pencils or markers or something as well. I'm just going to mark the sides that are corresponding. SI and LA are corresponding sides. So SI and LA correspond. And also we have IM and AR correspond. And also we have that third side corresponds. We have SM corresponds with LR. And we also have the similarity statement. Just like with congruent triangles, the order that you write them tells a lot about our similar figures. So in this one, we could name the first triangle any way we wanted. I'm going to name it SIN. So the order that we write the first one determines what order we have to write the second. So triangle SIN, here's our symbol for similar. It looks like a little squiggle, it's a tilde. And it is similar to, we have to put these in the corresponding order. So if we started off with angle S here, then obviously we have to list the corresponding angle first, which is M. Then we wrote I, so next we have to list A, and last we list M, so last we list the corresponding angle R. So our similarity statement, triangle SIN, similar to triangle LAR. This tells us which angles match up and also which sides match up. And this is going to be very important for us later when we try to find missing values. Okay, now let's talk about the scale factor. Scale factor is the ratio that compares similar figures. So if we're asked about the scale factor between triangle ABC and triangle WXB, it's saying, okay, let's match up the corresponding sides and reduce those fractions. So here, this one matches up with this one. So we can write that ratio AB over WX is 3 to 15. Now we can simplify that, and that becomes 1/5. Let's match up another set of corresponding parts. Here, AC matches up with WB. So that ratio, 6 over 30, we can reduce that ratio to 1/5. And our last set of corresponding parts, BC and XB, match up. So 5 over 25, which can reduce to 1/5. So you see all of them right here, our scale factor is always the same. Now with scale factor, it matters which one comes first. Since this one listed ABC first and then WXB, we want to list the smaller one first. If our question had asked in the reverse order, then we would need to use those symbols. But these ratios are what we use to find missing lengths in similar figures. So let's take a look at some problem. Here we go. These two triangles are similar. Let's find the missing link. So I'm going to use my colors. I'm going to highlight which ones match up together. These triangles are turned the same way. It's pretty clear which ones match up together and correspond. So this is the one we're trying to find. That's our x. So when we write our proportion, we're going to match up the corresponding sides. Now I always write my proportions in small to big, unless it's just asking for a scale factor and then the order letters. I will always write the smaller one over the bigger one just to be consistent. So I want to match up the parts that are corresponding. X over 25 equals, and since we listed small over big, we need to be consistent with that and do small over big here, which is 6 over 10. That's a geometry bar. And now we just solve that proportion. You can use algebra or you can use decimals. I'm going to do the algebra and multiply these together. And multiply these together, they're equal. So we have 10 times x is equal to 25 times 6. Solving, we get 10x equals 150. And when we divide by 10, we get x equals 15. And we should stop and ask ourselves, does this make sense? Is this a reasonable answer? And yes, this is. If we were to write our scale factor here as 6 over 10, that reduces to 3/5, which is the same when we compare our blue parts, 15 over 25, that also reduces to 3/5, so they do have the same ratio. Question 2. These two rectangles are the same shape, but one has been scaled up in size. What's the missing length of the larger rectangle? Okay, again, I want to use my colors. I want to highlight the parts that match up. The 5 and the 8 match up together. The 6 and this side, which is unknown, that's our x, match up together. So, set up our proportion. Match up our blue parts together and our green parts together. Small over large, this means 6 over x equals, and for the green part, small over large, 5 over 8. Now, so we can use cross multiplication, or we can use decimals. Let's give us 5 times x equals 6 times 8, which is 48. And when we solve this, we get 9.6. So if you plug these into decimals, just plug in 6 over x equals 5 over 8, and then look for the vertical line. You may have to zoom in some to see what the actual answer is, but pretty straightforward. So try this one on your own. I encourage you to pause the video, try this, and I'm going to work it out. I'll come back in just a moment with the answer. Okay, so if you pause the video and work this out, you should have gotten that x equals 5. The parts it correspond are 3 and 12, x and 20. So since I set my number always with small over large, x over 20 equals 3 over 12. Because the 3 over 12 equals x over 20, it's the same proportion. Okay, so let's move on. Sometimes we have triangles that it's a little bit harder to tell which parts match up together. Everything I showed you so far, the triangles between the same way. It was pretty clear which ones match up. This one is a little harder to tell though. So for this one, we definitely want to look at our similarity statement right here, because this tells us everything we need to know. It tells us which parts match up and correspond together. And remember that the order they're listed here tells us a lot. So when I look at this first right here, LK, I'm going to make a little mark over this just to indicate LK, my first two letters, and RQ here. Those parts match up together. So I'm going to highlight them with one color. LK matches up with RQ. Also, I'm going to underline this step. KJ matches up with QP. So that's KJ matches up with QP. And of course, our third sides match up. It's a little harder to indicate here, but first and last, LJ corresponds with RP. So we're trying to find two values here. We have x and y. Since we know about both of our green parts, we want to use that ratio and both of our proportions. We know that 6 over 18 is equal to, let's do our x's first. It's x over 25. And I'm also And when we solve these proportions, we should end up getting that x equals 10, and we get that y equals 5. Now, if you're using decimals right here, be very careful. The only variable you ever want to enter in decimals is x. So if you were entering this, you would put in 6 over 15 equals 2 over x, because we get the vertical line that intersects the x-axis. So that's why we would always want to use x. Okay, so let's try another one. These look more straightforward again, so I'm just going to highlight the parts that match up. The x plus 9 matches up with 49, and the 30 matches up with the 70. So when we write our proportion, let's do small over big, x plus 9 over 49 equals small over big, 30 over 7. Now, if you are doing algebra, you might see that you can simplify this fraction right here. You can reduce, and if you want to do that, go ahead. You should get the same answer whether you reduce or not. If you reduce, you'll be working with smaller numbers, whereas if you don't reduce, you're working with larger numbers. If you're plugging it into decimals, I would not even bother reducing. I would just plug in plus 9 over 49 plus 30 over 70. Just remember that when you're plugging into decimals, if you have something like this, x plus 9, remember that you would need to put that in parentheses. Anyway, when we solve this, we end up getting that x equals 12. Okay? So I encourage you to try this one on your own. Pay very attention to the similarity statement right here. Pause the video, try this on your own, and I'll come back with the answer in just a moment. Okay, if you pause the video and mark this out, hopefully you have labeled your figures the same as mine. Pay attention to the similarity statement. BC matches with SR. So that is this one here, that my blue ones match up together, and the green ones match up together. So when we solve this, we would end up getting that x equals 10. Okay, now let's try a couple more problems that are a little bit different. 3 problems right here we're just going to work out that have multiple triangles in the same picture. So in this picture, it says the given triangles are similar. It's very important that we first recognize that there are 2 triangles in this picture. There's obviously a big triangle, and then there's a second small triangle. So I would encourage you, when you do this, you'll always see me doing this, separate your triangles. Enjoying it, doesn't have to look great. Really good. But when I do this, it's a lot easier to match up which parts go together. So in this small triangle, this side is 3, this side is 7, and this side is 6. Even though it's a little weird where that 6 is supposed to take with this side right here. And in our big triangle, this long arrow right here indicates that this entire side is 18. This entire side is a question mark, so it's x. And this entire side is 6. So I'm going to highlight what matches up. The 7 and the x go together. The 3 and the 18 go together. And the 6 and the 36 go together. So when we go to write our proportion, we have a choice of what we want to use. We're trying to find x, which goes with 7. So we're definitely going to have to use 7 over x. Again, I'm doing small over large, so 7 over x. And we could choose, if we wanted to use the magenta color right here, 6 over 36, or if we'd rather, we could use the 7 and the x is equal to 3 over the 18. How are we going to get the same answer? These ratios are the same. 6 over 36, 1/6. 3 over 18 is still 1/6. So whichever way you go, you should still end up getting that x equals 42. Okay, try another one like that. There are 2 triangles in this picture, so let's separate them. Here's a smaller one, and there is a larger one. Excuse me. Again, my figures are not really done to scale, but they don't have to be. You just need to be able to get the correct information on them. We've got 13 and 11 in our smaller triangle. We don't notice by ourselves. We don't need to. In our larger triangle, we've got 26 over here, and we've got on this side 6x plus 4. Match up the corresponding parts. The 13 and the 26 go together. The 11 and the 6x plus 4 go together. So we would have 13 over 26 equals 11 over 6x plus 4. When you solve this, either by algebra or by decimals, and we end up getting that x equals 3. You might recognize that you could simplify this fraction here. If you did that, it would reduce to 1/2. So our scale factor here is 1/2. Now, here's our last problem right here. This one is a little bit trickier. There's to pay close attention to this one. The small triangle right here, going over in red right there. Always the public on this one. Okay, so the sides of our small triangle, they're pretty straightforward. This is x, this is 6. But on the big triangle, this is where students sometimes get thrown off. Our big triangle over here, the side is this 6 plus this 3. So this 6 plus 3, we add together, we get 9. The side, the right side of that big triangle is 9. It's not just this 3 down here, because 3 is only a part of the side, it's not a full side. So similarly, this side over here is got x, and down here is got 4. So how big is it? It is x plus 4, or 4 plus x. So pay careful attention to those. Make sure that you set up your proportions correctly. The x and the x plus 4 go together. The 6 and the 9 go together. And so our proportion would be x over x plus 4 equals 6 over 9. When we solve this using algebra or using decimals, doesn't matter, then we end up getting here that our value for x equals 8. And that's all about similar figures and proportions. If you have questions,